A former student of mine emailed me last night from Lake Tahoe, where they had received 6 feet of snow in the past 4 days. Can you imagine that compared to what seems like a interesting day outside here? The western storms are really quite terrific this year, if any of you are outdoor enthusiasts. So Mammoth Mountain in Southern California received 8 feet of snow last week. Squaw 6, Jackson Hole between 6 and 7. It's really quite remarkable. One storm after another is pummeling the West Coast. So today I want to continue and conclude the discussion about nuclear experimentation and have you think a bit more with me about guidelines for experimentation and how those might be embedded into law. And I also want to start out by having you consider the central challenges that were faced by the President, the Defense Department, and the Atomic Energy Commission, so that imagine yourself in the position of trying to figure out how rapidly to develop the nuclear testing program and how you might guide it and what the central purposes were. So underlying the plan and the research was really the need to understand what our resilience would be in the face of an attack. The construction of weaponry that would be deliverable was one problem, but that was more of a technical problem compared to wondering about how we might survive an attack. A central question associated with that is how to minimize human exposure, for what periods of time were necessary to prevent long-term illness, and how to decontaminate and restore the environment. Also, how to convince the public of the need for continued testing as evidence kept leaking out into the press in a variety of ways, but not in small part because of the availability of detection equipment. So Geiger counters were not a technology that was required to be licensed or under the control of the government. Also, the X-ray film, as I described, being overexposed when it arrived at hospitals, led people to understand that something was going on. They also faced the challenge of how to maintain their secrets. And they established a very large element within their bureaucracy to work on different processes to encourage workers to change their behavior in a way that would minimize the opportunity for leaking of secrets. And then the central question that we'll look at today is, if you have a population that's been seriously exposed, how do you manage them? How do you manage their complaints? What kind of provisions would you make for them in terms of long-term care or compensation? So in example after example, among the 2,000 tests that were conducted during this period, you find workers and military officials being intensely exposed. Those closest to the site experienced the highest degrees of radiation, often without recognition of what they'd experienced or without understanding. And something that was really quite remarkable following the test in the Bikini Atoll, when you had 100 ships that were lined up encircling the blast site, was that almost instantaneously they created a massive amount of hazardous waste. And they had no understanding of what the implications might be for dealing with that waste. And if you step back and you think about the location of the testing site in the middle of the Pacific Ocean, they were very conscious of what really has become a fundamental principle of managing the environment and producing environmental quality, which is the idea that dilution is the solution to pollution. So that the expectation that the technological danger will somehow dissipate as it moves further and further away from the point of release across space and time to pose no danger and eventually go away. And one interesting idea behind the presumption that pollution is just going to go away is that it's pretty easy to conclude that if you don't have sensitive detection technology. So if you can't see a pollutant, you can't taste it, you can't smell it, you can't feel it. If you don't have a technologically sophisticated surveillance system in place, people presume that it's gone away. So gradually they realized that they needed to understand this distributional pattern more carefully. But the assumption was that the atmosphere and the oceans provided almost an infinite sink and opportunity for diluting pollution. Interesting idea. So they looked at billions of pounds of hazardous waste in the form of these ships and wondered, well, what are we going to do with them? It's kind of curious what they did initially. They decided they were just going to spray them with water. So they brought boats alongside the ships and they started hosing them off, assuming that the radionuclides would somehow wash off into the sea. The sailors on the ships started scrubbing them with soap. Then they found that the nuclides didn't dissipate. They used solvents. They started bombing them with ground up coconut shells, and nothing seemed to work. It's kind of interesting here thinking too that these sailors are standing on the deck of an irradiated destroyer with no protection gear. Absolutely none. Actually, in 1987, in the Chernobyl nuclear power plant explosion, you see a similar degree of disregard for worker safety among those that were brought in to put the fire out and also to clean up the mess. Dramatic misunderstanding on the part of those exposed, despite the fact that the technical knowledge understanding the danger was pretty well understood among the people that were giving the orders to the GIs here. So one of the solutions was, well, let's bury some of it. We'll just sink some of the boats that are in the worst shape, or we'll find out what parts of the ship are most irradiated and figure out what to do with those pieces. Kind of an interesting thought. So you've got this atoll, which is basically the crater of an old volcano, poking out of the Pacific Ocean with a few strands of beach ringing it. You put 100 ships in there. You explode a bomb underwater. And Michael Oppenheimer, who was the first director of the Los Alamos laboratory, responsible for the design of the first atomic bomb that was tested at Los Alamos in New Mexico, Michael Oppenheimer warned very vigorously against exploding a nuclear device underwater, especially within an atoll, because it would create, in his words, a toxic soup that would persist and contaminate the coral, it would contaminate the underlying sands, and it would contaminate the water and marine life for decades. It would basically make that fisheries no longer suitable for human consumption. Quite interesting to see the moral and ethical arguments among the physicists who were responsible for the design of these weapons back at that point in time. Very compelling arguments not to use these weapons that were above a specific size. Oppenheimer and his close colleagues and friends were branded as communists and communist sympathizers. There was some legitimacy for that. He was a socialist in his own political thinking, but it was quite curious to see the way the Atomic Energy Commission attacked him and set up spies to follow him and see who he was associating with. You can now find this out by going back into this declassified documents database. And then the trials that eventually were held to remove him from the Atomic Energy Commission. So they've got this waste. They don't really know what to do with it. They began to take some of the ships and drag them back across the Pacific to U.S. ports. So here is an example of an aircraft carrier that was dragged into the port at San Francisco called Hunters Point. Anybody here from San Francisco? Well, you may know this area, next to the Bayview community. It's quite an interesting area. Well, they didn't really know what to do there, and this was an experiment in progress, an experiment largely without controls. But imagine bringing the radioactive waste into one of the largest cities on the West Coast that was surrounded by people, and then trying to remove the radioactive material from the ship by sandblasting it. And sandblasting is a notorious technology for simply grinding away at hard surfaces to remove the residues. And what happens to it? Well, basically it just goes up into the air or if it's foggy or if it's raining, it will rain down and then wash into eventually the bay. Hunters Point sits on the bay. So you can see Hunters Point in this map from Google Earth over here, and you see the Bayview district right now, only probably less than a mile from Highway 101. And like many other ports in the United States, the port at Long Beach, port at Newport News, Virginia, up and down the East Coast and the West Coast and the Gulf Coast, you really find a contaminated soup of a variety of different toxic substances, often in rather close proximity to very densely populated areas. So in this case, it's also quite curious that this is now the site of a very active protest. Many people that live adjacent to these military sites are quite concerned about their exposures. And it also is the subject, the target of a renewal effort in San Francisco. The San Francisco Redevelopment Authority hopes to take a 1,400-acre tract of land and redevelop it. This also happens to be a center of ethnic minorities in San Francisco, especially African Americans. And these people are quite concerned that the same redevelopment effect will occur at Bayview as occurred in the Fillmore district when the government came in, took over property, basically forced out tenants and the poorest in the community, and gentrified it, dramatically changing the socio and demographic characteristics of the area. So gradually by the late 1990s, we had a pretty good image of what happened to all of these radionuclides, at least in the lower 48. So the surveillance was best in the 48 states, also in Alaska, because Alaska was the site of a variety of underground tests by the U.S., but it also was the recipient of much of the fallout that came across from Siberia, where a number of the Soviet tests were conducted. So that the understanding of the distribution of risk was really quite sophisticated. I'd say probably more so than any other chemical that has been studied or regulated in U.S. history. So that these data were aggregated by the National Cancer Institute, county by county, and you can see the red pattern indicating areas that residents received the highest exposure, measured in millisieverts. And you also see kind of unusual patterns developing in the northern Rocky region, but also as far away as Indiana, Illinois, and then, as I showed you the other day, as the cloud had swirled down from Canada and met a rainstorm in New England, the Vermont-New York border as well. So this became the foundation for a rather interesting compensation scheme on the part of the government. So if you lived in specific states or in specific counties, you were presumed to have a certain dose of radiation. That made you eligible for compensation at specified levels, depending upon the illness that you could demonstrate. So you needed a physician's diagnosis of a particular illness. It might be thyroid disease, it could be thyroid cancer, it could be leukemia, it could be bone cancer, it could be different types of blood disorders, it could be genetic mutations, but if you could demonstrate that you had an illness that was plausibly related to exposure to an array of radionuclides, it was matched up against this map so that became the formula for a level of compensation. The people that lived downwind are called the downwinders, and $50,000 became eligible or became available to those that met the criteria, that were physically present, could demonstrate that they had residency in these areas for specific periods of time. The Radiation Exposure Compensation Act of 1990 provided for compassionate payments to individuals who contracted these cancers and other diseases as a result of exposure during the testing period, and also for those that were mining uranium that became the predominant fuel that was enriched to produce the nuclear fuels. Those that mined the uranium, but also those that that transported, so that the miners and the transporters were well recognized as another occupational group that experienced high levels of exposure, as well as elevated incidence of disease when compared to individuals that had received lower doses of radiation. So a payment of $75,000 was available to people that were on-site participants. In other words, they were actually stationed there. The military officials that you saw with the goggles and sitting in the lawn chairs with the shorts on, or those on the decks of the cruisers, or those that actually were involved in moving into the region and working on the boats and trying to figure out what to do with the mess. So those that had participated in restoration efforts also were eligible. Here's an example of a uranium mine worker spending a good amount of time underground and being dosed at a really significant level on a routine basis. So $100,000 was available to those that had been employed either above ground or below ground if the mines were located in certain states and if they had worked at any time during the period beginning in 1942 and then ending in 1971. So this is kind of interesting to me because it really is an example of the government saying, well, here's a trade-off. You know, we really need to conduct this test. We know that these damages are likely to accrue. Let's develop a scientific foundation for understanding the probability of the link between, a causal link between the exposure and the adverse health effect, and we've got to figure out a way of compensating these people. That this is an approach Congress thought would subvert class action lawsuits, and they were largely right. My nephew, as an example, works for the Justice Department, and he works on Native American claims for those Native American communities that were believed to be intensely exposed. So he goes to the community, he interviews people using a fairly extensive survey form. He tries to figure out their medical condition, and all. This is especially problematic, you can imagine, for impoverished groups because they do not have adequate medical care. So that they also, given the absence of routine care, it's very common for the poorest in society to develop illnesses that progress until they're quite serious before they are diagnosed. So the wealthier in most societies have access to medical care that allows for early diagnosis, early treatment, so that the ultimate damage is often less among the wealthy. There was a political science professor who was trained at Yale and argued in an article that being richer is being safer in the world quite generally. So that the richer have higher educations, they have a higher capacity to understand risk, they have also a higher capacity to take action to manage risk. And in the event of damage, they either are able to receive compensation from insurance policies that they paid for, or they have the opportunity to go out and seek high-quality medical care. It's an interesting kind of an argument. So richer is safer, written by Aaron Wildavsky, who was a rather famous political science professor at the University of California. So what's happened in terms of these compensation efforts? The downwinders, those that simply lived in the area, have now received about $600 million. About 12,000 different claims have been approved. The on-site participants have been awarded about $91 million. The uranium miners and the millers have received about $600 million, and the ore transporters about $24 million. So a total of about 20,000 people have been compensated at a level of $1.3 billion. Now, back up and think, well, how many people actually were exposed during this period of time? Well, the Cancer Institute did an estimate, which was rather revealing. By studying tissue samples from around the world, their estimate by the mid-1990s, when the total world population was roughly 5.7 billion people, their estimate of those exposed was 5 billion people in the world exposed. So any sort of a compensatory scheme such as this would have to set boundaries, would have to set limits. And our limits were set at our national border, despite the fact that we contaminated tracts of land in different parts of the world. And it was not as easily predicted as you might imagine, given the role that climate played relative to the intersection of the rainstorms with the dust clouds, and also the long residency time of the radionuclides in the atmosphere. So that Mexico, Canada, parts of Europe were very heavily exposed, but they did not have any compensation scheme in place. Now I'd like to switch gears for a moment and talk briefly about medical experimentation. And you may recall from earlier history courses that the Nuremberg trial in 1946 produced eventually consensus about ethical guidelines for human experimentation. Well, the Nazis were quite active at experimenting on humans and violating most principles that now have been adopted by nations or among nations, and also principles that have adopted by medical associations around the world. So the Nuremberg trial was conducted in reaction to horrific experimentation without seeking consent, without providing knowledge about what the purpose was, what the risks might be, without anesthesia, so that there was no sense of what the humanitarian benefit might be, and also kind of raising a rather interesting question. When you think about medical experimentation, how should you conceive of the locus of the balancing that would go on? You know, a fundamental principle of medicine is at first, the first principle is do no harm. Well, experimentation may do harm. If you conduct a clinical trial using a new drug, or you wonder about a new technology such as a nuclear weapon or exposure to waste from a nuclear reactor, then you need to think about you know, what the net benefit to the person might be. Is it okay to think about this question as one where the individual that is exposed deliberately in the experiment, whether or not the net benefit should be balanced against the individual damage? In other words, is it ethically responsible to think that a collective benefit in terms of making the world safer, if you believe that, by experimenting with nuclear weapons and trying to figure out what our resiliency would be, does it make sense to balance that against harm that would be accrued by the individual? So that now when we think about the design and license of a new drug, we construct the calculus of good versus harm at the level of the individual, as opposed to at the level of society. So for years I debated with chemical industry officials about the ethical nature of claiming that it's okay for us to be exposed to pesticides in food and drinking water, or the farm workers breathing the fumes in the air as a plane flies over. It's a case we'll talk about more over the next couple of weeks. Is it okay to justify that based on the claim that, well, you know, if you use pesticides, then we're going to produce a lot more food in the world, so that we'll avoid starvation, we'll avoid diseases. So that's an example where you conduct the calculus at a very gross scale, saying, yes, the population is exposed to these chemicals at relatively low levels in drinking water and food, occupationally at a higher level, but it's really worth it because we want to balance that over the net collective benefit of having a nutritious and sufficient food supply. So that these are the basic questions that were addressed in the Nuremberg trial, but also surround the question about how to manage compensation efforts. So 23 medical doctors were on trial for murder, torture, and other atrocities, performed in the broad name in their testimony of medical science in concentration camps. Now, in response to this, the American Medical Association eventually adopted guidelines that included these: voluntary and understanding consent of the subject, prior animal experimentation, appropriate medical supervision. Those treated were expected to accrue some benefit. or there should be some overwhelming humanitarian purpose that's served if the benefit would not be accrued by the individual. So thinking about these guidelines and then thinking about the Atomic Energy Commission's approach themselves to experimenting with humans is an interesting topic. And if you go back and take a look at the Department of Energy files, which you can do on their website, if you simply take a look at the release of documents that occurred during the 1990s, many of which had been classified, you'll see a whole array of experiments. Here's an example of isotope injections at Brookhaven National Lab, where the individual being injected had no knowledge of what he was being injected with, no understanding of the radioactive tracers that were being used to understand how these compounds get distributed in the body. So, I mean, one of the concerns at that point in time was, we're releasing this technology, we're creating all these new radionuclides. How do they behave inside the human body? Well, we all know that radioactive tracers now are used to track the movement of different pharmaceuticals to the body to make sure that they can reach the target organ and actually cure an illness or a particular problem, such as a bacterial infection. So that being able to understand the movement of chemicals through the body, where they reside, what their persistence is, what their metabolic rate is, how they break down into other products, and whether or not those are likely to be excreted by urine and feces or excreted by water vapor from your breath. So these are all questions that are circulating in their minds and provided in their thinking a rationale for experimenting on humans without asking for their permission, without telling them the logic behind it, and with no presumption that the individual would benefit from that exposure. So 81 studies were conducted that involved children's participation or participation by pregnant women in radiation research. 21 of these were supported by federal funds determined to be non-therapeutic. In other words, no benefit would accrue to the individual that participated. Now also think about this, and think about the logic of employing children and whether or not it is reasonable to assume that a child would have the capacity to understand the nature of the risk, to understand the perceived humanitarian benefit of participating in the research, and also to be capable of self-monitoring for physiological effects that might be associated with the exposures. So, by the way, we fall down in this expectation that children somehow should be capable of understanding risks via education or via product labeling, whereas there are 80 million children in the United States today that really have quite limited capacity to understand the nature of the kinds of environmental threats or environmental health threats that we've been discussing so far in the course. Now that, to me, is quite interesting. If you choose to educate or to label as a management strategy to contain risk or to manage a technological hazard or pollution, another good example of that would be the way we manage mercury in fish. We don't set a limit for mercury in fish and then take the fish that are contaminated beyond the limit out of the marketplace. Instead, what do? We post signs on the side of a riverbank or on the side of a lake and assume that that sign is going to be sufficient as a warning device. Do not consume more than X amount of fish taken from this river. The logic being to contain their mercury exposure. So the idea that you've got a large proportion of the public that is either illiterate, that is not technically competent in order to understand the technical nature of the warning, or not capable of managing their own health in response to an adverse event. So here are a couple of examples of the way that the Atomic Energy Commission was thinking about this. Here, the AEC medical advisor is recommending the suppression of evidence of plutonium injections, so not informing people that are part of experiments. There are a large number of papers, he argued, that do not violate national security but do cause considerable concern. Papers referring to levels of soil and water contamination surrounding AEC installations, idle speculation on the future genetic effects of radiation, and papers dealing with potential process hazards to employees are definitely prejudicial to the best interests of the government. Every such release is reflected in an increase in insurance claims, increased difficulty in labor relations, and adverse public sentiment. Very, very curious. So, they're arguing that a logic for secrecy, a logic for not seeking informed consent, is that it's going to make their life tougher. You could use the same argument to basically scuttle a surveillance system. So basically argue, well, let's not monitor where this stuff goes, because if we do, then somebody's going to find out about it, and it could be used against us. It could foster public opinion that would cause Congress to react to their constituency and argue, gee, we shouldn't continue with this testing program. So they're very deeply into this line of logic, trying to figure out how they can maintain public support, but how the very act of conducting surveillance or environmental monitoring could undermine their long-term plans. In another example, at Vanderbilt Hospital, between 1945 and 1947, 829 pregnant women were fed radioactive tracer cocktails. Another at the University of Tennessee at the College of Medicine and the John Gaston Hospital, 2 African-American women, ages 22 and 33, were administered iodine-131 while they were nursing infants 4 months in age. And both mothers had been diagnosed with thyroid cancer. This is curious. You take mothers that had thyroid cancer and you would dose them with iodine, which lodges in the thyroid, that had been irradiated. Infants continued to nurse, and the levels of iodine-131 were monitored in the mother's breast milk and thyroid and the infant's thyroid. The infant's accumulation of iodine-131 in their thyroids was significant, prompting the researchers to warn against administration of iodine-131 to lactating women. So the thinking here that they understood clearly that the nuclide moved from mom to the young, to the kids, via breast milk, but they really had no concerns about what the long-term health effects might be on the women. At Harvard, Boston University, and Massachusetts General Hospital, there was an experiment conducted on what they then called mentally retarded children in 1961 at the Wrentham State School. And it was designed to understand whether non-radioactive iodine could block thyroid uptake of radioactive iodine or iodine-131. The National Institute of Health, the Atomic Energy Commission, and the Quaker Oats Company also conducted a similar study at the Walter Fernald School in Massachusetts, also described by the AEC as being a school for the mentally retarded, and the children were fed breakfast food containing radioactive iron and calcium. Quaker Oats Company? Now that's interesting. Quaker Oats was extremely concerned about contaminants moving into their processed foods, and they were also worried about whether or not they might be able to block the uptake of some radionuclides by fortifying some of their foods with other nutrients. So could you put calcium in oatmeal, and would that have an effect? Well, perhaps that's an interesting study. Perhaps you would want to carry that study out on animals before you conduct it on children. And why would you choose the Wrentham School or the Fernald School as a locus of this type of study? So 9 boys between 10 and 15 years in age and 1 21-year-old served as subjects. And they were divided into 2 groups, one receiving intravenous injections of calcium-45 and the others received it orally in their breakfast cereals. And they were trying to figure out where this went in the human body and what role it played in blocking uptake of other nuclides. And several letters were sent to the parents of the students who would become members of the science club if they agreed to participate. So the first appeal was made to the students, would you like to participate? And it's kind of interesting to think about the letter that was sent to the parents. I'm going to read this to you. It gives you some insight into their thinking and their methods. Dear parent, in previous years we have done some examination in connection with the nutritional department of the Massachusetts Institute of Technology. with the purposes of helping to improve the nutrition of our children and to help them in general. And for checking up on the children, we occasionally need to take some blood samples, which are then analyzed. The blood samples are taken after one test meal, which consists of a special breakfast meal containing a certain amount of calcium, no mention of the radionuclide. We have asked for volunteers to give a sample of blood once a month for 3 months, and your son has agreed to volunteer because the boys who belong to the science club have many additional privileges. They get a quart of milk daily during that time. They're taken to a baseball game, to the beach, and to some outside dinners, and they enjoy it greatly. I hope that you have no objection that your son is voluntarily participating in this study. The first study will start on Monday, June 8th, and if you've not expressed any objections, we will assume that your son may participate. Interesting. So, first, the presumption that they would legitimately ask the child before the parent. The presumption that if they heard nothing back from the parent, who might be traveling or whatever, that they would go ahead with the experiment. These studies, once they were released and came to the attention of the Department of Energy and President Clinton in 1995, led the administration to issue an executive order on declassification. So during the 1990s, the Clinton administration was responsible for declassifying almost 400 million pages of material. 20% or so reduction in the total backlog, but the new declassification programs new classification programs have been initiated by the CIA, the National Security Agency, and the National Reconnaissance Office. So that this period between 1990 and 2000 was a period where we were declassifying more than we were classifying. And following 2001, September 11th attack on the World Trade Center, we've clearly gone in the opposite direction. The Department of Energy was extremely embarrassed by the release of these studies, and the former Secretary, Hazel O'Leary, undertook what she called an openness initiative in 1993, and went back through all of her records of the Atomic Energy Commission, and once that was transformed into the Department of Energy, the Nuclear Regulatory Commission, and declassified a large amount of information. The National Security Administration is now the largest intelligence agency in the world, and it is important to know that they have power to classify at all levels, and they also are exempt from the Federal Freedom of Information Act, which means that you cannot request any information from them, or they have the ability to make the judgment to decline any request and not give you any reason for that. So last year we spent, this is actually a year and a half old now, we spent almost $25 billion on secret programs for surveillance, for containment, technologies to eavesdrop via computer, reading emails, also watching the way that people surf the internet, so that the surveillance efforts on the part of the government that remain classified have never been higher in human history. So let's pause and reflect over the past couple of lectures and think about some of the key lessons. One lesson that is extremely important, and I hope 5 years down the road, if I have any hope of you remember anything about this course, I want you to think about one issue, and that is, if you want to manage the environment, you've got to think a lot about the principle of persistence. How long does a danger persist? How is it distributed? How does it move through the environment, the atmosphere, the water, the soils, and the food? And I'm struck, I'm really struck by the importance of food as being a primary route of exposure to many of the radionuclides in this case, but it's also the primary route of exposure to many pollutants and other synthetic chemicals in the food supply today. I gave a lecture yesterday afternoon on regulation of food in the United States, and I came to the conclusion that food is often the predominant route of exposure, and you often need to think about controlling air pollution because of how it might get into the food supply. So really, the strontium-90 story, the iodine-131 story, and also the cesium story as well, is one about air pollution. It's about having the idea that it's okay to release this material to the environment and that it's not going to come back to haunt us in the form of water pollution or air pollution. But where it seems to pose the greatest amount of threat, where it concentrates the most, is in the food chain. So if it gets into the atmosphere, it's likely to get into every other compartment of the environment, and then it's likely to boomerang back to us in the form of a food contaminant. This case demonstrated also the length of time, the enormous amount of science that needed to be conducted in order to figure out what happens to these chemicals in the human body. Yes, you could think from a medical researcher's perspective that it was legitimate to think about the need for human experimentation to figure out where these compounds go in the human body, and also to think about the need for long-term medical surveillance to figure out what the effects of exposure at different doses might be. But there are experimental guidelines that you could now imagine that you would want in place before the government would have authority to conduct those types of tests. This is a case, probably the best case in the history that we've got, the history of environmental science, about expert understanding of a dose-response relationship, understanding what dose posed a specific threat, and also it is perhaps the first case in the United States, at least, where we had an understanding that these chemicals behave very differently in the fetus. They behave very differently in people that have different genetic characteristics. They behave differently in the young compared to the old, and that they concentrate in different parts of the body at different ages. So this idea of susceptibility that now has become a hallmark of U.S. environmental law, and really a fundamental principle of European environmental law, looking and thinking about everybody as not being average, but looking at differences in physiology and these other characteristics. Susceptibility is now an extremely important factor in thinking about risk, and therefore becomes a critical foundation for thinking about different risk management strategies, like setting levels for allowable contamination in air, food, and water. Don't forget in this case as well that this entire history took place between 1945 actually, the first test, and 1963, when the atmospheric testing stopped via the Limited Test Ban Treaty. So in this compressed 18-year period, what environmental laws did we have in place to control exposure? We had nothing. We had no Clean Air Act. We had no Safe Drinking Water Act. We had no Toxic Substance Control Act. We had no Superfund Act to try to figure out what to do with these highly contaminated sites. We had no Food, Drug, and Cosmetic Act that looked at radionuclide levels in different foods. We had no Food and Drug Administration that might be responsible for looking for radionuclides in different types of foods. We had no understanding of whether or not the chemicals bioconcentrated during the process of taking a raw corn and turning it into corn oil, or extracting the water out of a grape to make a raisin. So that none of this regulatory authority existed during this 18-year period. So at the same time, what we'll see over the next several weeks is that this history is extremely important in providing a paradigm for understanding environmental quality and the distribution of pollution that was picked up and was dropped into food safety law, dropped into air quality law, dropped into thinking about hazardous materials management. So it's become a very important component of environmental law. Also, later in the term, when we think about the current status and the future of nuclear power, we're not going to move into this discussion too deeply today, but I want you to think about the similarity between what we learned by 1963 and then what we learned from the Chernobyl event. So Chernobyl is a nuclear reactor located in just outside of Kiev in a little village called Pripyat, and it exploded and it caught on fire, and the roof blew off of it back in 1986. And I don't know, let's see, 1986, I suppose that you would not, most of you would not have been alive in 1986, but your parents would remember this. And you are walking around probably still with radionuclides in your body that resulted from your intake of foods that were contaminated, as the amount of material that reached the atmosphere also went into global circulation, also rained down around the world, and exposed almost everyone at a lower level than was experienced during the atomic weapons testing era. A couple of key points of comparison here. One is that the expectation on the part of the Soviet government, then responsible for managing this site, was that they needed to manage and test for contamination in close proximity to that site. They were most worried about getting people out of that zone by evacuating them out within roughly about a 10 to 15 kilometer radius. If you remember that donut, remember the donut that I had up there surrounding the map in Nevada that demonstrated the way that the Atomic Energy Commission had similarly underestimated the movement of radionuclides. The same happened here. Gradually, after they expanded their testing, they found that the eventual distributional pattern is designated by the red on this map as the most intensely contaminated zone. So if you look at this, you see that certain of these zones were confiscated. Some were confiscated even more than 150 miles away from the site of the fire. There's a very important story here about the absence of surveillance leading to a perception of environmental purity. So that gradually over a period of time, you know, as the Soviet Union collapsed and the amount of surveillance expanded, the quality of the testing got better, they realized that these nuclides had seriously contaminated a huge tract of landscape in the Eastern European nations. And they basically made agricultural productivity impossible. They made future forestry in this area impossible. The forests surrounding Kiev now have taken up the radionuclides. So if you cut those down and you build a house out of the material, you basically would be exposing yourself or your family to the material. Or if there is a serious forest fire in that region today, and there's been about a 6 or 7 year drought in Eastern Europe, so this is a serious concern, that forest fire would basically cause these radionuclides to go back up into circulation. Just as on Bikini Atoll, where they decided, well, you know, let's restore the site, let's take off the top meter or two of soil, and we'll bring in fresh soil so that they can grow crops again. They still thought that this would be the effective restoration technique in the Ukraine, but they found that it was an overwhelming area that had been contaminated. 3,200 square kilometers, 76,000 square kilometers had detectable levels of radiation, and 3 million people lived in these zones. So what do you do with it? What do you do with the structures that have been contaminated? What do you do with the equipment that's been contaminated? In this case, they decided they were going to bury it. So they dug deep trenches and they buried the military equipment. They dug trenches. They drove the fire trucks into them and buried the fire trucks. They buried cars so that they basically figured, well, this is one solution to the problem. In a slight aside, it was kind of interesting that when they would bury the cars, people would be watching as they buried the cars, and then they would go and dig up the cars and take the car parts out at night and then sell the car parts on the black market. There's really quite a similarity here between the problem of creating hazardous waste such as this that's been contaminated by nuclear debris in Chernobyl, and the idea of creating irradiated hulks of ships and wondering what to do about it. So that, you know, once again, we'll see a kind of a pattern of denial followed by a pattern of gradually increased sophistication and surveillance, leading to a recognition that oh my gosh, this problem is much bigger than we thought it was. So a few concluding thoughts about this section. One is that secrecy is a very important form of social control or regulation. So if we give the government the right to maintain secrets, we're giving them the right to control our knowledge, to control our intelligence. In this case demonstrates that secrecy concentrated knowledge among those with authority and power. It basically inhibits broad public literacy and intelligence. It undermines democracy because if you don't understand these issues, you certainly are not going to be an effective participant in decision-making about how to manage risks. And these are often pretty technical decisions. It prevents accountability. So the bureaucrats inside the Atomic Energy Commission and the Defense Department like this part about it very much. It basically means that they're not accountable to anybody except to those that also have security clearances. It may restrict individual liberty, as it has, restricting rights of 9/11 detainees. It can enhance the persuasive power of elites. It provides them with narrative advantage to give their interpretation of the story. So if you don't have the evidence to test or to contest their conclusions, you have no political power. And also, it turns secrets into extremely valuable commodities. So in a sense, secrecy creates intellectual property. The more valuable that property is, the shorter its half-life is. I'll leave you with one thought from Albert Einstein. It's not enough for a handful of experts to attempt the solution of a problem, to solve it, and then to apply it. The restriction of knowledge to an elite group destroys the spirit of society and leads to its intellectual impoverishment. Okay, thank you. Have a good weekend.